Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving greatest integer function, right? So in this lecture we are going to take up a very interesting problem from definite integrals, and here we have to find the value of this integral that is from 0.3 to 1.3, and here the integrand is greatest integer of 2x, right? So let us call this integral as I, right? Now in order to solve these type of integrals, what we usually do, we make use of the definition of greatest integer function, and first we'll try to redefine this function or the integrand, that is greatest integer of 2x, within these limits, that is zero point 0.3 to 1.3, right? So here we see that the lower limit is 0 0.3 and the upper limit is 1.3, right? And let us take the integrand as f of x, that is equal to greatest integer of 2x, right? So here x varies from 0.3 to 1.3, right? So we can now write this fact as x belongs to this interval, that is 0.3 to 1.3, right? So it means that x varies from zero point 0.3 to 1.3. So when x varies from zero point 0.3 to 1.3, then 2x varies from, will multiply these two numbers by 2, right? So here we have zero point 0.6 and here we have 2.6, right? So x varies from zero point 0.3 to 1.3 and 2x varies from zero point 0.6 to 2.6, right? So now here we can draw the real number line, and here we have 0, here we have 1, here we have 2, and here we can take 3, right? Now let us represent these two numbers on the real number line, right? Now zero point 0.6, it lies somewhere between 0 and 1, and here we have 0 0.6, right? And 2.6, it lies between 2 and 3, and 2.6 lies somewhere here, right? And now we can see that between 0 0.6 and 2.6, we have two integers, that is 1 and 2, right? And we know that whenever we come across with greatest integer function, our main objective to search for integers, right? So 1 and 2 are the two integers which belongs or which lies between 0 0.6 and 2.6. Now let us redefine this function f of x, which is greatest integer of 2x, from 0 0.6 to 2.6, right? So now here see, when the value of 2x, it lies between 0 0.6 and 1, right? So what we basically do here, will divide this interval, that is 0 0.6 to 2.6, into three intervals, right? So the first interval is from 0 0.6 to 1, right? From 0 0.6 to 1. Then the second interval is from 1 to 2. So here we'll write 1 and here we will write 2, right? And the third interval is from 2 to 2.6. So here we'll write 2 and here we will write 2.6, right? So we are redefining this function, that is greatest integer of 2x, from 0 0.6 to 2.6, and for this we'll divide this interval, that is 0 0.6 to 2.6, into three intervals. So the first one is from 0.6 to 1, and then the second one is from 1 to 2, and the third one is from 2 to 2.6, right? So when this number, that is 2x, it lies between 0.6 and 1, so we'll write here, that is 2x, and here we'll write less than symbol, right? So when 2x lies between 0.6 and 1, right, then the value of greatest integer of 2x, by the definition of greatest integer function, this must be equal to 0, right? Because see, when 2x lies between 0.6 and 1, that is 0.6 and 1, then the value of greatest integer of 2x must be equal to 0, right? Now when 2x, it lies between 1 and 2, so here we will write 2x, right? So when 2x lies between 1 and 2, then again by definition of greatest integer function, the value of greatest integer of 2x must be equal to 1, right? And when 2x lies between 2 and 2.6, then the value of greatest integer of 2x must be equal to 2, right? So here we have the three integers, that is 0, 1 and 2. So here we have 2x, right? So this is how we can redefine this function f of x, which is greatest integer of 2x, in these three intervals, right? Now let us solve these three inequalities, right? So now if we divide this inequality throughout by 2, then we'll get here zero point 0.3, and here we have simply x, because the 2 get cancelled, and here we have a half, right? And when we divide this inequality by 2, then we have here half, that is 1 over 2, and here we have x, and here we have 1, right? And when we divide this inequality by 2, we'll get 1, and here we have x, and here we have 1.3, right? So now we see that from these three inequalities, the initial point is 0.3, which is our lower limit, right? And the final limit or the upper limit is 1.3, right? And we have to integrate greatest integer of 2x from 0.3 to 1.3. So we have 0.3 to 1.3, right? So the purpose of redefining this function in these three intervals is to break this integral I as a sum of three integrals I1, I2 and I3, right? So I1 goes from 0.3 to half, I2 goes from half to 1, and I3 goes from 1 to 1.3. So now we can write the first integral I1 from 0.3 to half, and then we have I2 from half to 1, and then we have I3 from 1 to 1.3, right? And here we have greatest integer of 2x dx, here also greatest integer of 2x dx, and here also greatest integer of 2x and dx, right? Now see, when x lies between 0.3 and half, the value of greatest integer of 2x is 0, right? So here we'll have 0. And when this x lies between half and 1, then the value of greatest integer of 2x is 1. So here we'll have 1, and when x goes from 1 to 1.3, then the value of greatest integer of 2x is 2. So here we have 2, right? So now we can write I is equal to 0.3 to half, and here for greatest integer of 2x we have 0. So this is 0 dx. Then we have half to 1, and for greatest integer of 2x we have 1, and then we have 1 to 1.3, and for greatest integer of 2x we have 2 and dx, right? And the value of this integral, it disappears, so here we have 0, and the integral of dx is x, and the limits are from half to 1, and here the integral of 2 dx is simply 2x, and the limits are from 1 to 1.3, right? So now we can simplify this expression. So this is 0 and here we have half to 1. So we'll substitute the limits and we'll take the difference. So we have 1 minus half, and here first we'll take x is equal to 1.3. So this is 2 times 1.3 minus, then we'll take x is equal to 1 here. So we have 2 into 1, and this is 1 minus half is half, and here we have 2.6 minus 2, and this is half plus 0.6, right? So now we can write this expression as half plus 6 over 10. So this is 10. The LCM is the LCM of 2 and 10 is 10. So here we have 5 and here we have 6. So I is 6 plus 5 is 11 over 10. That is equal to 1.1, right? So viewers, the value of this integral is 11 over 10 or 1.1, right? So this is how we can solve these type of definite integrals involving greatest integer function, right? And here we have seen how to redefine this function f of x, which is equal to greatest integer of 2x in these three intervals.